All right, find the volume of the solid. I have two parabolas, y equals 4x minus x squared, and y equals 8x minus 2x squared. And I've graphed my TI calculator from on the board. It's about the axis, x equals negative 2, which I drew it in red. And we're gonna make that solid about this way. Now here's the problem. If I try to make the volume equal ay dy, I can find my limits, 0, and I suppose I can figure out that this is 1, 2, 3, 4, 5, 6, 7, 8, you know, and I can go 0 to 8. I can figure out the limits of my ay, but then you'd have to solve both of these curves, right, for x. And I don't know how to solve either of these curves for x. So this is the case. I don't want to do both methods. I just want to do a different method, okay? I want to do 2 pi x f of x dx. All right. What I mean is that there's no way. Your only choice is cylindrical shells. All right?
Yeah.
And what you have to witness, everybody, is we are taking, be clear, a cylindrical shell has a differential of dx. Do we all agree? That's this differential. That is the thickness. Then you have to have a distance, and if I draw that differential up here, you have to have a distance to it, which is the circumference, 2 pi x. Well, obviously this time, this distance I just drew right here is not x. This time, if I bring the 2 pi out, the distance there is not just x distance of the differential, but it has this 2. So it's x plus 2, or x minus minus 2. And actually a lot of students memorize this, but I always think of it that way. And then we need the height of this differential. And we look here, it goes from the top curve to the bottom curve. That differential this time, or that height, not the differential, I'm sorry, the height of that curve this time is what? 8x minus 2x squared minus 4x minus x squared dx. Yep, x is the distance, f of x is the height of the shell, and dx is the thickness. Now dx is going to 0, right? We're infinitely thin. That's the whole idea here. We're adding up these infinitely thin shells. Last thing, you got to have limits of integration. Just because your calculator can do it doesn't mean you should. Everybody, if you can look at this and try the integers 0 and 4, you'll find that those are the intersections, right? Much faster. And again, I would not want to do this by hand. Could I? Absolutely. All right. Well, yeah, I argue that looking is faster. Then I don't want you to solve it. What I don't want you to do is put this in solid. All right, and I don't want you to do even the intersection here. That you guys follow me? I mean, you don't want to waste time. And again, pretty easy problem. You make this integration, you have it.